Hello everybody, this is a video about tree diagrams. I am your magical host, Mr. Shirley, and I hope you're as excited about this video as I am. I hope that you've printed off the note that I put in Classroom to go with this, so you can fill in some of it as we go through. Onward we go. So, tree diagrams are just a way of organizing probabilities when there's more than one action or choice. Okay, you can use it when there is only one choice, but it's a lot less useful and a whole lot more work that doesn't really seem necessary. Okay, it's especially useful when some of the outcomes can be different depending on the choice. Okay, and I'll get into that a little bit more. The tree diagrams, I know trees grow from the ground in real life, but you can have them go in basically any direction. So my first tree here, I'm going sideways from left to right. You can decide how you want to do it. So for the first question here in the chart, the spinner below is spun twice. So you have options of A, B, and C. So your first part of your tree diagram, again, is A, B, and C. Okay, so that's your first choice will be one of those, or first result, I guess. And then your second result will just be A, B, and C again. So this is just how things are organized in a tree diagram. So your first spin is A, and after that spin, the only possibilities then are A, B, or C. So you could have A and then A, or A and then B, or A and then C. You see where we're going with this. So it's a way of organizing somewhat larger amounts of data, but again, you would not want to do this for something where you might have 10 choices or 50 choices or something like that. The tree would just get absolutely ridiculous. But for medium amounts of information, it works just fine. Now, the sample space, if you recall from last week, is basically all of the possible outcomes that you could have. Okay, so you could have A and then A and then B, A and then C, B and then A, and so on and so forth. So you should have 9 of these. One thing just to keep note of as you're going through this chart and as you're looking at these sample spaces is that the number of things in your sample space should correspond to a little bit of simple multiplication. Okay, so we're spinning this thing twice. So the first time you've got 3 options, and the second time you've also got 3 options, because basically each time you have 3 that you could spin. So you would do 3 times 3, meaning that you should have, which of course equals 9, which means you should have 9 possible results in your sample space. Okay, and I'll go over that with the next example too, to hopefully just make a little more sense. Okay, it's also known as the fundamental counting principle, but I really don't think you need to know that. Just recall that math works. Okay, so you've got 9 total results that you could end up with. All right, so it's just a way mainly of making sure you're not forgetting anything as we're going through. So the probability questions here. So the probability of getting B twice, okay, so that's B and then B, or you can just look in your sample space and there's only one that's B twice, so that's 1 out of 9, okay? And back to this fundamental counting principle again, you'll notice that this is also the same as the denominator. Okay, remember the denominator in the probability questions are all possible outcomes. So that's the number of possible outcomes you could have. So we have 9 possible outcomes, so 9 is the denominator. Okay, so the probability of at least one A, meaning AA would fit, or AB, or AC, or CA, and so on. So there's 5 of those, so you could have you would have 5 over 9 be your probability there. And I will give you a moment to try C, just so you can experience the magic of probability for yourself. Okay, I'll assume you all did that and got it just right. So the probability that there's no C in it is 4 over 9. Okay, hopefully everyone kind of stuck with me on that one. We'll do one more, and then you'll be off to the races to finish the rest of the chart that I included. So a popcorn stand offers buttered or unbuttered popcorn, so that's 2 options in 3 possible sizes, small, medium, and large. So you've got 2 options for your first choice, 3 options for your second choice. So this time I did the the tree downward for no particular reason, just to show you that you could. So your first choice is buttered or unbuttered, and your second choice is small, medium, and large, and small, medium, and large for buttered and unbuttered. Now you could flip this around and you could have 3 branches of small, medium, and large up here, and then buttered and unbuttered for each of them at the bottom. So it doesn't really matter the order that way for these questions, but it's usually best to stick with the order that the wording of the question has. Okay, so using our fundamental counting principle again, because we've got 2 options to start, and then each of those has 3 options, so our first choice is between 2, our second choice is among 3, and I'm sure you can all do that multiplication, but I'm going to write it here anyways in very ugly pen. That means we should have 6 possibilities, and I'm having some smartboard issues, surprising as that might seem. Okay, so we've got 6 possibilities. Okay, so the B just means buttered, SML is small, medium, and large. Okay, so our sample spaces are those 6 options. Okay, so I'd like you to take a moment and try and answer the questions A, B, and C just on the side there. Try them before, so pause the video, try them out, see what you get, and then we'll go through them in a moment. I've got some equal signs here because you should reduce them to lowest terms, so that's a bit of a hint for you. Okay, so I'll assume you got those. So the probability of it being buttered is 3/6, because 3 of the 6 options are buttered, so you could look at it on the tree, you could look at it from the options in your sample space, and that reduces to 1/2. The probability of large, similar idea, so you've got 2 possible large options out of your 6 in the sample space, which reduces to 1/3. The probability of small with no butter, so unbuttered small, there's only 1 of those possibilities, so that's 1 out of 6. Okay, so hopefully that illustrated a little bit why those are useful and how to make that tree diagram. They can be used for other things besides probability, but they are generally pretty useful for this kind of thing where there are multiple choices going on. Okay, and again, usually you wouldn't want to use it for just one choice, but you could use it for many choices, more than 2. The only thing is, the farther you go, the bigger it gets, so you don't want to go with too many choices. So please try out the chart. Let me know if you have any questions, and I hope you have a great day.